The story of Ethernet is best told in personal stories shared by its very own creators, providers, and users. The Voices of Ethernet archive is dedicated to preserving Ethernet's oral history, recording pivotal events that may have been forgotten or remain unknown, through a collection of spoken records with the individuals engaged in the technology's global emergence as the foundation of Internet.
Today we're talking to Rich Seifert, one of the people behind Ethernet Stories. Thanks for joining us, Rich. Could you please introduce yourself?
Sure. I'm Rich Seifert. I was at Digital Equipment Corporation back in the 1979-1980 timeframe when I was given the opportunity to work on this networking thing with these guys out in California.
Just checking, were you volunteered or voluntold?
Well, you know, DEC, working at DEC is like playing pinball. The reward for success is you get to play again. And so I came off a fairly successful project and I got my choice of what do I want to work on? And it was all sorts of various interconnect technologies. My background is in radio communications and high-speed analog circuit design and, you know, RF transmission and that sort of thing. And it turns out that skill set is really important when you're designing what at the time was a very, very high-speed network like 10 megabit per second Ethernet.
So you mentioned you were at DEC, right? And I believe you worked under Gordon Bell. We have talked to Gordon and he's an amazing guy, but I wonder what it was like to work for him.
Well, you know, at DEC, everyone worked for Gordon Bell. Gordon was the vice president of engineering. Yeah, I worked for Gordon, but a few layers down. Yet I did have to interact with him. Gordon was a real hands-on guy. And, you know, you'll talk to Gordon and you'll put his talk up, but I had the honor of working with one of the true visionaries in the computer world at the time. And I've said many times, DEC went out of business. DEC, you know, disappeared off the map in the late 1990s. But the beginning of that demise was the day Gordon left, which was in the early 80s, 82, 83 timeframe, because there was no visionary. And so, you know, DEC survived for 15 years on their installed base, but they lost the sight of the future. That went with Gordon. But it was a pleasure and a challenge to have Gordon going in and out of my lab.
Oh, so you mean he came down and tried to tell you what didn't work and what should work?
Oh yeah, oh yeah. Gordon was very hands-on, especially with the projects that he thought were crucial. And I worked on a couple of the crucial projects. The original VAX development, which I worked on before I got into the Ethernet project, and Ethernet was, you know, high on Gordon's list of critical technologies for the future. So he wanted to make sure that the development moved along quickly and at a high degree of excellence. Gordon had the vision, and he was right, that the future of circuit board layout was CAD, computer automated design. Back in those days, we were laying out circuit boards literally by hand. And
I've seen that, and those the nice big wide pretty traces that people have drawn by hand.
The big traces, and you're doing it by hand. We had PDP-15s, which were ideal for that sort of application. And Gordon would go in and say, "But we can automate this whole thing. We can have computers do the layout. They'll be much more efficient. They'll be much faster." And then Gordon's mind is running, and he says, "We can fire all the layout guys." And I go, "Gordon, please don't fire all the layout guys. I gotta get my boards built next week."
So what you really needed to do was get the idea of Gordon and then sort of divert him off to the future track for a while and then get your guys to go and build the thing you'd already decided on.
Exactly. You listen to Gordon, you get the idea down, and then you go execute. And don't let the guys talk to Gordon until they're finished.
I know that talking to Gordon, his view was the VAX to succeed needed Ethernet. I'm just wondering how that came together when you were there.
You know, I fell into networking quite easily because of my communication systems background. I'm not a computer designer. I'm not a digital circuits designer. I worked on the VAX, but I worked in the area of signal integrity and electromagnetic interference and all of the high frequency aspects of it.
And just checking, what was high frequency for you in those days?
Well, 10 megabits was high frequency for us in those days. Yeah. In fact, we were beaten up in the marketplace for setting Ethernet at 10 megabits per second because people go, we don't need anything that fast. What we need is a reliable 1 megabit per second pipe is more than adequate. And they were right. Ethernet was expensive, at least initially. A VAX Ethernet card, it was actually 2 cards. It had, 200 integrated circuits on it, Schottky TTL, and it sold for thousands of dollars. The transceiver, if people remember the old battleship, the transceiver, which was my design, or I was responsible for the design of the transceiver and all
that. That had lots of analog-y stuff in it, right?
Lots. It's all analog.
Yeah.
That was a $400 device. And quite honestly, we released the Ethernet specs in 1980. It had to be a decade before there was a computer that could actually fill that pipe. I think the first computer that could actually fill a 10 megabit Ethernet was something like a 486 Pentium class machine, which was, late 80s, early 90s. The VAX couldn't keep it full. Nobody needed 10 megabits per second. In fact, 10 megabits per second is pretty fast even today. Now, I'm talking on a machine that has a gigabit Ethernet port, and probably you are too, and so are most of the people watching this. You don't need gigabit on your desk. Why do you have it? It's cheap, and it's commodity, and it doesn't make any sense to put anything slower in because the slower stuff wouldn't be any less expensive. And so you put gigabit in, and very, very few people need it.
But you do find reasons to do it because it does make your backups much better to your NAS.
Sure. If you're doing, if you're doing high-speed backups, you're not going to be limited by gigabit. You're going to be limited by disk speed. And so there's always a limitation.
Yeah.
But back then, 10 megabits per second took this big, ugly cable. This is, almost half an inch in diameter.
It is the fat yellow coax from which all rules descend.
This is the fat yellow coax with the black markings every 2.5 meters. And I spent hundreds of hours doing analysis.
Just for our listeners, and the black markings are important because?
The black markings are important because the original Ethernet, today Ethernet is a point-to-point technology. You plug, an RJ45 or a fiber optic connector into one device, and you plug another one into a switch or a hub or a server or something like that. And it's all point-to-point, and that's actually much easier. Back then, Ethernet was hundreds of devices, hundreds of these guys hanging in the ceiling off a single shared big fat yellow cable. And that's a difficult transmission line problem. You've got a cable that's up to 500 meters long with up to 100 things hanging off of it with capacitive and inductive loads. And you've got reflections and you've got impedance discontinuities, and all of those things look to the transceiver like noise of one form or another. And what you want to make sure is that you can reliably decode the data and reliably detect carrier and detect collisions, because without that, the algorithm doesn't work. So that was my contribution, was all of that high frequency signal analysis, the cabling, the connectors, the transceivers, the circuitry that talk to them. That's all high frequency analog circuitry. Now we look at 10 megabits as being, as being slow, and the clock frequency in your computer is multiple gigabits, and Ethernet's running at 10 gigabits and 40 gigabits and more. But back then, 10 megabits was a challenge, specifically with silicon. We picked 10 megabits because we felt it was the highest speed we could do with the silicon that was available in 1980.
So if I go sideways a little bit, so I understand you were at the first IEEE 802 meeting. So what can you tell us about that? Because that must have been an interesting experience.
IEEE 802 was a reaction to the publication of the Ethernet spec by DEC Intel and Xerox in September 1980. The very first copy that ever came off the laser printer, September 30th, 1980, and the next day, in fact, my boss rewarded us. We flew back from Palo Alto to Massachusetts in first class. 802 was an industry reaction. The marketplace was saying, "Oh my God, these three companies are going to set the standard. They will be the leaders. We're going to have to follow." And the general tone of IEEE 802 was, "We're not going to let them shove Ethernet down our throats." Now, in the end, the first IEEE 802.3 specification, 802.3 becoming the official name of the IEEE standard version of Ethernet, it's almost identical to what we published 1980, 1982. And Ethernet became, the de facto standard. IEEE 802 is now a self-fulfilling prophecy. They're in the business of holding very nicely catered and arranged meetings in some of the most beautiful places in the world. Originally, it was pretty much all domestic. Germantown, Maryland, and San Diego, and various other places. And now it's Beijing, and it's Europe, and it's all over the place.
Just in their defense, I've been to a lot, and the Beijings and the Viennas are pretty rare amongst the Orlandos and the San Diegos and St. Louis and similar places. I think what you told us is when we first started, there was a great suspicion about Ethernet being pushed by three companies, but I believe it was publicly released without licensing. Was that correct?
Well, it was publicly released without copyright.
Yeah.
So we wanted people we gave away copies of the specification. Anyone who wanted one, from an undergrad student to an engineer at a competitor, everyone and his grandmother could have a copy of the Ethernet spec. In order to build Ethernet equipment, you need what's called an organizationally unique identifier, or an OUI, which gives you the first 24 bits of the 48-bit address. And we charged an administrative fee for that OUI, primarily because we didn't want every graduate student to have an OUI. There's only 16 million of them, and there's more than 16 million grad students. So we charged $1,000 for that. And any company that's going to be building, millions of Ethernet devices, that's in the noise.
And this was very different to the competing technologies, which were much more of a lock-in.
Yes. So yeah, you paid your $1,000, you got your OUI. What you may not have noticed was, on the back page of the paper that you got when you paid your $1,000, was you got a worldwide royalty-free license to use the Xerox Ethernet patents, which were issued in the early 70s. Now, they expired in the 90s, and now Ethernet is, the original patents have expired. There's lots of other patents. But at one point, Xerox even dropped the trade name registration for Ethernet. So anyone can call anything Ethernet, and they do. Ethernet started off as a specific speed, a specific cable, a specific, packet format, a lot of specifics. As Ethernet developed into its different variants, we now have, I don't know how many zillions of different Ethernet medium, 10 base T, 100 base T, gigabit, fiber, various other cables, wireless and personal area networks and whatever. About the only thing left from Ethernet is two things. The packet format. An Ethernet packet has a preamble and addresses and a type field and a checksum and data. That's pretty much been kept for the last 40 years. And Ethernet is a concept. It's a concept of high bandwidth networking with as little intelligence as possible in the network. It's the exact opposite of telephony. Traditional telephone systems have very simple devices, dumb telephones that sit on your desk that have nothing in them but a speaker, a microphone, and a ringer. And all of the intelligence is in the network, is in the central office and the switches. Ethernet's the other way around. There's almost no intelligence in the network. The network's just a pipe. It's a way to get packets quickly from one place to another. All of the smart stuff, the packetization, the reassembly, the reliability, that's all in the higher layer protocols, which is all running in the end stations, the clients and the servers. So we keep the network simple, means we keep the network cheap, which means we can make lots and lots of them. I don't even know what the numbers are up to. There's got to be billions of Ethernet ports of one sort or another in use in the world today.
There's been a lot of twists and turns in Ethernet. Were there any that particularly stood out to you as being particularly interesting? I
was skeptical at first that you could get Ethernet to run at 10 megabits, much less 100 megabits, on twisted pair wiring. I remember being dragged into the office of the president of digital equipment, Ken Olson,
yep.
Gordon Bell's boss, if you will.
Another very famous name.
Another famous name. We used to call him KO. KO called me, into his office, and he said, "Rich," picked up a piece of this stuff. He says, "This is nuts. This is expensive. This is difficult to install." He says, "Why don't you do it with twisted pair that a school teacher can hook up using a pocket knife?" And I go, "Well, it's a little more complicated than that, Ken." And he says, "Well, back in the day, people told us we couldn't run, the clock in the back of the PDP-1 without, special things, but we ran it and it worked." And I go, "Yeah, you might have gotten away with it." But one of the things that was drilled into me as an engineer at Digital, it's not about getting it to work. You can get anything to work. It's, can I get this to work, make 10 million of them, and not have a large number of them come back as defective or problematic or cause problems in the field. So it's gotta work, but it's gotta work in huge volumes with very high reliability. And first impressions are important. If we put Ethernet out and it was flaky, it would have that reputation forever. There was a 1 megabit networking technology that was popular at the time called Corvus OmniNet. Nobody remembers Corvus anymore. They made disk drives that could be shared by Apple II computers because disk drives were expensive in the mid-late 70s. It worked sometimes, and it didn't work other times. And people learned you just couldn't depend on it. Ethernet, we shipped 10 million of these off the first revision of the circuit board. And we didn't do a second revision of the circuit board because there was a problem. We did it for cost reduction, because if you can knock $1 out of the cost of a product, and you multiply that by 10 million, you've just made $10 million. So that was the key to Ethernet. It was cheap, it was reliable. I was surprised that they could get 10 meg to work on twisted pair. Of course, as they got to faster, 100 meg Ethernet and gigabit Ethernet, all of which I worked on, we found that we had to make the wire better. You can't run fast Ethernet or gigabit Ethernet on 1970 grade telephone wire. You need, Cat 4 or Cat 5, and then Cat 6, and now we've got Cat 7. I actually had a cat that was named Cat 3. He was my third cat. And I never really upgraded him to Cat 5. I have Cat 4 now.
Someone else made the point to me that the twisted pair that sort of coincided with the breakup of the Marbell, and all of a sudden there was all this cable in the world that people could use.
Exactly. In the 1980s, the Bell system broke up and people could own their own telephone systems and own their own building infrastructure. So, if you're building a new building, everyone was stringing this structured wiring systems, point-to-point wire from every desktop back to wiring closets on the floor, and then backbones that would interconnect the floors to a main, communications room where you'd put your telephone switch. Well, 10BASE-T leveraged off that infrastructure and said, okay, well, you can run your telephones that way. He says, hey, you got 8 wires in that cable. You're only using 2 of them for telephone. We'll use 4 of them for Ethernet. And sitting next to that telephone switch down in the communications room, we'll put a bunch of Ethernet switches or servers, and we'll just leverage off that infrastructure. That was a great idea. The marketing brilliance of Ethernet is to make the technology open and give it away and let everybody make it, even if you have to pay a small license fee for the patents. Let everyone make it. Now, you're going to get a smaller slice of that pie, but it's going to be one big pie.
So when I think about this, the key was to make it adoptable or consumable, right? Not just cool technology, but something that people would actually consume.
Yes, and to make the standard, to make the specifications, first of all, understandable, and second of all, such that a person who hadn't attended all the meetings, who didn't know all the history, who didn't know why this specification said this, but just saw the specification, could go into a closet, maybe not even being a native English speaker, build a product, and it would be interoperable with products made by everyone else around the world. That's why, for example, even in the original Ethernet spec, the specification for the access control algorithm is not in English. It's not in any human language. It's in Pascal. Now, people joke about Pascal today, but it was popular back then. And it didn't matter that it was in Pascal. All that mattered is that it's in some computer language form, which means that it's non-ambiguous, because human languages are always ambiguous. If they weren't, we wouldn't have wars. And so, for example, when the first 802.11, the first Wi-Fi standard was about to come out, I was on that committee as well. I cast a negative vote for the release of the Wi-Fi standard on the basis that the specification for the Wi-Fi access algorithm was written in very complicated English. There was no machine language formulation. And in that, I think I personally delayed the release of 802.11 for about 6 months while they went back and did, they didn't do it in Pascal. That's fine. I think they did what's known as a state machine formulation. But that's fine. Anything that's unambiguous is fine, because people have to be able to make interoperable products without speaking any particular language.
Are you following along with current developments in Ethernet?
Not so much. I mean, I see what's going on out there, and I'm still subscribed to some of the email reflectors. But quite honestly, I spent 35 years of my career doing Ethernet and building companies that used Ethernet, and finally retired. And I officially attended my last IEEE 802 meeting. I think it was in 2002. So it's now almost 20 years.
So sort of moving on, we found an article online about Rich Seifert's top 10 list of stupid networking ideas. What prompted you to write such a thing, and give me one of your favorites?
Well, what prompted me to write that is I was asked to be the keynote speaker at a local computer networks conference it was in Florida in 2001. And I always like to make a splash. So I put together a presentation, the culmination of which was my top 10 stupid networking ideas. Back then, ATM was the buzzword. ATM, asynchronous transfer mode, was going to be the be-all and end-all of networking. It was going to replace Ethernet. It was going to replace everything. It was ATM, from coast to coast. And I looked at it and I said, this is never going to fly. And so ATM is my number one top 10 stupid networking idea. And I think I was absolutely right on that one. And a number of the other ones I was right on pretty much all of them. Some of them we still use, even though they're stupid. I thought anything that was what I called Ether not, token ring, FDDI, ISO Ethernet, integrated voice data video, networks, replacing the telephone system with the internet. Now, yes, a lot of telephone traffic today runs on IP, but it runs in the telephone company backbone, not on the internet. The internet is not the telephone company backbone. The telephones, company may connect to the internet, and they may use IP on their own backbones. The whole cellular network industry changed the face of telephony, such that desktop telephones hardly exist anymore.
So, as a shameless plug, what do you think about our idea of recording this? I mean, I think I've explained to you what I'm trying to get to is the conversation you might have in a coffee shop or a bar, and I want to get to it before we lose these stories.
Yeah, I want to get to it before we lose these people. We've already lost a few good friends and colleagues from back in those days, and so I think it's a good idea, and I think you're smart in starting with the earliest players, because in 10 years some of us aren't going to be around. But then take it forward. Go talk to the people who did 10BASE-T, the Pat Thaylors and the people at Hewlett Packard, and then the people who did fast Ethernet with Grand Junction Networks, and everyone ended up at Cisco sooner or later. So they did. I mean, Cisco acquired, all of these companies. The J. Sri Ulals and the people who came later and added their stuff, and the people that are doing it now, who I don't even know their names anymore, because they came into it after I left. So yeah, good idea. Capture it. A lot of it is captured. A lot of the gory detail you'll find captured in books written by some of the same people. So that's there too.
Okay. Any final thoughts?
Yeah, I thought about that. Speaking to engineers and software developers and marketing people and whoever's out there in the beginning of your career, you never know what project you're going to work on that's going to change your life and possibly change the world. I was 27 years old, 26, 27 years old, when I got the opportunity to work on this thing. I had no idea what Ethernet was. I didn't know much about networking. I was an RF guy, but they said, oh, you get to travel out to California a lot. I said, well, that sounds like fun. Ended up moving to California, at a much later date. I didn't realize that by choosing to work on the Ethernet project versus something else, that would set the tone of my career for the next 35, 40 or more years. And that fortunately, due to my work and that of many, many others, Ethernet became what we called it back then, which was the RS-232 of the 90s, the ubiquitous universal communication system, even though physically it doesn't bear any resemblance to what we did back then. I'm glad I chose to work on the Ethernet as opposed to something else. I have friends who have spent their entire career designing memory chips. That's got to be the most boring life in the world.
All right. So, Rich, look, I almost can't thank you enough for this conversation. And we really appreciate hearing from you. So, again, thank you very much for your time.
Oh, thank you for having me, and keep doing this. Get more people and keep Ethernet moving forward.
Tune in to hear other voices of Ethernet as we continue to document the evolution of Ethernet since 1973 and explore where the technology's story might go next. Thanks for joining.